Hi everyone! In this video, I'm going to discuss some examples of sorting algorithms. But before I show you these examples, let me first introduce what is a loop and what is a list. A loop is a programming structure that repeats a sequence of instructions until a specific condition is met. We as programmers use loops to cycle through values, add sums of numbers, repeat functions, and many other things. In other words, loop is used to repeat a certain step or procedure until a condition is met. Let us first have our example for a loop. Write an algorithm to find the sum of numbers from 1 to 5 without using summation. So let's say, for example, in some part of your algorithm, you write something like this: the summation of I, where I is equals to 1 up to 5, or manually adding up these numbers just like this: 1 plus 2 plus 3 plus 4 plus 5. So the aim of this algorithm is to show you how loop algorithm works, okay, or how a loop structure works on your algorithm or program. So let's start. Step 1 is start. Step 2, declare variable n as 1 and sum as 0. And then check if n is less than or equal to 5. So this is the condition. If n is less than or equal to 5, we will proceed to step 4, or else go to step 5. Now, step 4, add n to sum and add 1 to n. And then go back to step 3. And then step 5, display sum. And then step 6 is stop. So you will understand this algorithm once we check our iterative process for this algorithm. Suppose I have this table, so n is basically equal to 1 as stated in our algorithm. So declare variable n as 1 and sum as 0. So we need to say they have an initial value to start with. Okay, and here is our condition: is n less than or equal to 5 as stated in step 3. So n is less than or equal to 5. So I write these columns in order for us to track down the values of these variables, okay, and also the answer for the condition. Okay, and then so let's start with this: check if n is less than or equal to 5. So is n, which is equal to 1, less than or equal to 5? Since n is equals to 1 and it is less than 5, so the answer is yes. And in step 3, if the condition is true or yes, we will proceed to step 4, which is add n to sum. So sum will be equal to, sum is equals to 1 plus 0, since n is 1 and 0, or sum is 0. So now the value of sum is 1, and then add 1 to n. So since n is 1, so we will add 1 to it. So 1 plus 1 is equal to 2. So we will just place the value of this sum here to our sum, and then n to our n. Okay, so let's check if n, which is equal to 2, is less than or equal to 5. Since n is less than or equal to 5, so it's yes. And then again, we will add n to sum. So n now is 2 and sum is 1. So I mean to say sum is equals to 2 plus 1, and that is 3. And then n is equals to 2. We will add 1 to n. So I mean to say that's 2 plus 1. So now the value of n is 3. So we'll just place it in here in our first two columns. And now we will check if n is still less than or equal to 5. Since n is equals to 3 and that is less than or equal to 5, so the answer is yes. So again, we will go to step 4 to add n to sum. So that's 3 plus 3. So our sum is 6. And then 3 plus 1 for n. So that's 4. Okay, and then n is equals to 4. Is it less than or equal to 5? So yes. So again, we will just add n to our sum. So 6 plus 4, so that's 10. And then for our n, we will just add 1 to it. So n is now equal to 5. Now let's check if n is less than or equal to 5. So here, as you can see, it's either less than or equal. So still this would return, or this condition is still yes. Okay, so if that is yes, we will proceed to step 4. So sum is equals to 5 plus 10, and that is equal to 15. And then n is equals to 5 plus 1, that's 6. Okay, so is 6 less than or equal to 5? No. So that's the time that we're going to break the loop, since um, we're just iterating this algorithm since n is equal to or less than or equal to 5. But now it's greater than 5, so therefore we will go to step 5. So this is how the loop has terminated. And then in our step 5, we will display the sum. And what is the last value of sum? That is 15. So if we're going to check 1 plus 2 plus 3 plus 4 plus 5, it would result to 15. Okay, so 1 plus 2 is 3, plus 3 is 6, plus 4, 10, plus 5 is 15. So this is a trial and error creation of this algorithm. So it doesn't go like the first try you would get the correct algorithm. So you have to try and critical think on how we're going to, or what are the variables that you needed in this algorithm, and how the process worked, and how we were able to use the loop. Okay, so the next one is the list. So what is a list? A list is a collection of elements of the same type. So I mean to say, if that's a list of numbers, then therefore the list only contains numbers. If that is a list of names, then the list should only contain names, or let's say words or fruits, or let's say vegetables. So it's on the same type. So it could be represent, or it could represent a group of numbers, words, names, and any other forms of data that you could retrieve later on, like email addresses and contact numbers. So here are some examples of a list. So let's say there's a list of names. So I mean to say, we could only have names. So John, Mary, and Steve. So as you can see, it is enclosed in a double quotes. So just like in our Excel, wherein we represent text and enclose it inside a double quotes. Okay, and then numbers, so 9, 3, 5, 48, so any numbers. And then email addresses, wherein there's a formatting. So it could be lspusec@hotmail.com or ac1l@gmail.com. Okay, so in this module, we will use algorithm to manipulate data in a list. Okay, so implementing list to algorithm. So it's just one example. So write an algorithm to sort a set of numbers in ascending order. So here is the list of numbers. Step 1, start. Step 2, declare I as 1, j as I plus 1. So I mean to say, the value of j depends on the value of I. N as the maximum number of elements in our list, which is 6. So you just have to count the number of elements in our list. So 1, 2, 3, 4, 5, 6. So we need to say automatically n is equals to 6. Okay, and then a as the variable containing the set. So I mean to say, it's just like a is equals to, so that would be the name of our list. Okay, and then step 3, when accessing elements, indicate the name of the list, which is A, and then use I and J as the position in our list and represent it as a subscript of the list A. So an example, A sub I. So I'm going to say, if I is equals to 1, and then this is A sub 1, meaning to say you're referring to one element, which is 9. Okay? And then step 4, check if j is less than or equal to n. If yes, go to step 5, else go to step 7. And then step 5, we will compare if a sub I is greater than a sub j. So as you could remember, j is depends on the value of I, and then we add 1 to it. So I mean to say, if a sub I points to 9, then therefore a sub j points to 4. So we will compare which of these two number is greater than the other. Okay, so if yes, swap both elements, and then if not, well, of course we're not going to do anything, so it stay at this as it is, and then we will increase the value of I by 1 and then go back to step 4. So we'll just go back to step 4. We're not going to proceed in step 7 yet. Okay, so once we're done, so we will go to step 7, check if the list is in ascending order, and if not, reset the value of I to 1, then go back to step 4. Okay, and then stop. So let us have an example of this algorithm. So I just copied the list of numbers, and then is initially at value of 1, j is equals to 2 since I is 1, and j is equals to I plus 1, so I is 1, 1 plus 1 is 2. And then n is equals to 6. Well, of course, that's the number of elements. And then the name of our list is A. And then in step 3, when accessing elements, indicate the name of the list, which is A, and then use I and j as the position in our list, and represent it as a subscript of the list A. So meaning to say, we will assign a position or index to the specific element. So for example, the first element is equal to or has a position of a sub I or a sub 1. Second element is a sub 2. Third element is a sub 3. The fourth element is a sub 4. Fifth is a sub 5. And then the last one is a sub 6. Okay? So now, we will move on to our step 4. So check if j is less than or equal to n. So is j less than or equal to n? Yes, because j is 2 and n is 6. If yes, go to step 5. So compare if a sub I. So what is a sub I? Since I is equals to 1, so that's a sub 1. Okay? Remember, I is equals to 1 initially. So a sub 1 is equals to 9. Is greater than a sub j. So what is a sub j? J is equals to 2. So therefore, that's a sub 2. And a sub 2 is 4. So we will compare if 9 is greater than 4. Is 9 greater than 4? Yes. So if yes, swap both elements. So look at this elements. So we will just swap them. And then increase the value of I by 1. And then update the value of j since I is 2. And then j is equals to I plus 1. So 2 plus 1 is 3. And then go back to step 4. And then we will check again if j is less than or equal to n. Since j is 3, so that is less than 6. So we'll go to step 5 and then compare again. So what is I? I now is 2. So that's a sub 2, and a sub 2 is equals to 9. So is it greater than a sub j? So what is a sub j? J is equals to 3. So technically, a sub 3 is equals to 6. Now, is 9 greater than 6? Yes. So we will have to swap both elements. Okay. And then go to step 6. Increase the value of I by 1. And then update the value of j. So j is equals to I plus 1. So since now I is 3, then j would become 4. And then go back to step 4. So check if j is less than or equal to n. So since j is 4, is 4 less than 6? Yes. So go to step 5 and then compare a sub I. So, and a sub I is greater than a sub j. a sub I is equal to 9, and then a sub j is equals to 7. Since 9 is greater than 7, we'll swap them both, and then add 1 to I. And then update the value of j, so that would become 5. And then again, a sub 4 is 9, a sub 5 is 2. So let's swap 9 and 2. And then update the value of I, update the value of j. So a sub I is 9, and then a sub j is 1. Is 9 greater than 1? Yes. So therefore, we'll update the value of I by 1, and then add the value of j, or let's say add 1 to the value of j. Okay, so that's 7. So we will check now in our step 4 if j is less than or equal to n. So j is equals to 7. Is it less than or equal to n? Since j is 7, it is greater than 6, so we'll go to step 7. So let's check. Check if the list is in ascending order. As you can see, it's not yet in ascending order. So if not, reset the value of I to 1, and then update the value of j, then go back to step 4. So the value of j will be updated. So I, or j is equals to I plus 1. So therefore, since I now is reset by 1, reset to 1, j would become 2. And then we have to start all over again, comparing these values one by one. Okay, so that's it. So here's a shell sort, another sorting algorithm. So I'm just going to let you watch what is shell sort. So how it sorts the numbers one by one. So I'm gonna let you watch the animation until it's done sorting these elements. Actually, this sorting algorithm is much faster than the first one. And by the way, the first algorithm is called the bubble sort. After this sorting algorithm, we will discuss another sorting algorithm, which is called the selection sort. It's a pretty simple implementation of sorting algorithm, and also it is faster than the first, or the bubble sort. So here's another YouTube link for you to check or visit. And then let's say given the following list of numbers, 5, 2, 8, 9, 3, and 6, and then 1, sort it in ascending order using selection sort. Okay, so here's another selection or another animation. So we have to group each elements into sorted or unsorted. So initially, the sorted part has an empty element, and then the unsorted part, of course, has all elements. So we will consider the first element as the lowest element, so that's 5, and then we will compare one by one the lowest element to the rest of the elements. So we will compare if the next element is lowest than the initial lowest element. So is 5 lower than 2? So it's not, so we will just replace the lowest element by 2. Okay, until we find another lower element. So once we've determined or we visited all the elements in our list and got the lowest element, we will place the lowest element to the sorted group and continue to the rest of the elements. Okay, so I'll let you watch the animation until it's done. As you can see, it has a faster implementation than the first one. So you could also visit this YouTube video for more information about the selection sort. So that's all for now. Thank you for watching.